Hello and welcome to this tutorial for using smart contracts with Emergence. Today we're going to look at reading from smart contracts and writing to smart contracts. We're going to show you how to get the transaction status of a given transaction, and we're also going to show you how to use this with OpenSea as an example. This tutorial follows on from getting started with Emergence. You don't need to have done VRMs in Unreal to use anything here, but you definitely do need to have done the Emergence Quick Start tutorial. We'll have a link to that video in a card now and also in the video description. Additionally, an example of this can be found in the Emergence sample project. We have a separate video on the Emergence sample project which you'll find in a card now or in the video description. You can find the sample project on our releases section at github.com/Crucible Networks Ltd/Emergence SDK Unreal. Go to our releases section and then go to unrealsampleproject.zip and download it. As I said, everything I explained today is available in the sample project, but today I'm going to be walking you through it as a step-by-step process explaining how the system works so that you can adapt it to your needs. So to get started, let's look at reading from a smart contract. It's important to remember before we start that all NFTs are smart contracts, so if you can talk to a smart contract, then you can talk to any sort of NFT, whether that be an ERC721 or an ERC1155. Smart contracts have read methods and write methods. Read methods cost nothing to call, they don't cost gas. Write methods cost gas and allow you to alter the state of the smart contract. So for example, if you've got an NFT, then getting the metadata of the NFT, which is a call to URI or token URI, is a read method, whereas minting an NFT is a write method. So before we get started implementing a contract, first we need to set up the contract and deployed contract assets in Unreal Engine. So right-click on the back of your content browser, and you'll now see you've got this Web3 submenu, and you've now got contract and deployed contract. So click contract, and then give it a name that's relevant to the type of contract you're making. We're going to be calling this one simple counter contract. Then open it up, and you'll see you've got an input for your ABI, and a button that says find methods, and then two read-only variables here, read methods and write methods. So you go and find your ABI, which you can, for this one I've gone on Etherscan, and I'm going to go down to contract ABI, and I'm going to press copy ABI to clipboard. The contract's ABI, or application binary interface, is what allows the Emergence EVM server to know what methods a contract has. This contract here is a super basic smart contract where it contains a table where every address that talks to the contract has a incrementing integer associated with it. So every time you write to the contract, you increment your address's integer. That's all it does. You're probably wondering, why would this ever be useful? Well, honestly, it isn't very useful. It's just an example smart contract that's very easy to understand because of how simple it is. It has two methods, one for reading your current integer and one for incrementing the integer. These methods are called getCurrentCount for getting current count and incrementCount for incrementing the current count for your address. I'm going to press copy ABI to clipboard, and then I'm going to paste that into the ABI slot here. And then once I've done that, I'm going to press find methods. And that'll find all of the read and write methods that are relevant to this contract. So here we've got getCurrentCount, and current count are the read methods, and the write method is incrementCount. Press save, close that. Then right click again, and we're going to make a deployed contract. And we're going to call this one simple counter deployed contract, and here we're going to enter the data about the actual contract on the blockchain. So we need its address, which again we can go back to Etherscan and copy the address from the top, paste that into address. We can click on contract, and this will open up a drop down, and we can select the one we just made, which was called simple counter contract, and we can select the blockchain, and the ones that will come with the Emergence package for you here are these 5, and we're just going to select Goali, because that's the one that it's on. So we're going to press save again, close that, and now you've got your contract and your deployed contract set up. I'm going to do all of my work today inside of third-person character because it's convenient for me to show it you there. So now let's have a look at how we can get the current count. Firstly, we need a button to trigger the message to display. So I'm going to pick J, just because it's unused. So I'm just going to type J in and try and find keyboard event J. Drag off of the pressed event, type read method. Select our deployed contract, so the one we've just made is called simple counter deployed contract. Select the method name we want to call. I'm going to call get current count, and then just add the parameters for it. So for us, we need to get the current, the currently signed in wallet address. Now you could of course hard code this, but we want to get the currently signed in one, so we're going to find the Emergence service, get Emergence service, which will bring you up this Emergence node, and we want to get the current, we want to get the cached address, which is when you've signed in with the overlay, this will be the address of the currently signed in user. And then we want to drag off of content, do make array, and then just plug that straight into there. And secondly, we want to drag off of when the read method is completed and do a print. And we're going to want to print this response, but this response is a JSON object, so we need to convert that into a string. Luckily, Emergence comes with some helpers, so if you go to Emergence, helpers, you can either convert it to a string or a string array. If you convert it to a string, that will effectively be just a flat JSON object, and if you convert it to a string array, this might be a lot more useful for you for having a nice clean output. Because when you get a response from a read method, it can contain multiple returned values, because that's how Solidity works. However, we know that this one is only going to return one value, so we can just get that one by just doing get and then the index of the thing, which is obviously going to be 0 because there's only one, and just plug that into the print string. Press compile and save, and then go and play the game. So first things first, we need to open the overlay so that we can sign in, because currently we won't have the cached address available to us. If we were to press J, it will just throw an error into the output log saying that it couldn't do the call because you don't have an address. So I'm just going to open up my MetaMask on my phone. I'm going to scan the QR code. I'm going to press connect to this site and sign this message. And then we're going to close the overlay by pressing Shift Escape. When you're in, it's worth mentioning now that when you're in the editor, you would press Escape to close the overlay, but if you pressed Escape whilst in the editor, what would happen is you would close the running in editor game. So when you're in editor, to close the overlay, always press Shift Escape, and that basically applies for any game in Unreal Engine anyway. So now, if we press J, we'll get the number 15, because that's the amount of times that I have I've actually called this contract before with this account. So now let's move on to doing a write method. So to get started with the write method, first let's go back into third person character, and we've got our read method here, and now let's make a write method. So I'm going to put K as my key press to activate the write method. So just the same as before, type K in and just try and find it in the keyboard events. So here we have it, K. And then off of the pressed line, do write method and select your deployed contract. So again, simple counter. Select from the drop down the thing we want to use. So for me, it's going to be increment count. Here you can send an amount of ETH, which I think is in Way, or the equivalent for your EVM chain of choice. Here you can set the content, and I believe we don't need any content for this one, but I will just check. So I've just gone to the simple counter contract again. I'm going to go to write contract, check the increment count, and it does just have write. It doesn't take any. It doesn't take any input. You can even see this in the code here. If we go to increment count, it doesn't have any variables, any parameters you have to send to it. So we can just leave content blank. Local account name is only useful if you're using local accounts, which we are not. We are using a wallet connected account. A local account is when you set up Emergence to make use of a public-private key to connect to an account, which is useful if you're setting up like a multiplayer server, something where you can't actually log in with with Wallet Connect, but on a client you'll usually want to be just using Wallet Connect, and to just use Wallet Connect you just leave this blank. Again, if you're using Wallet Connect, you don't need to set the gas price here. Number of confirmations is the amount of confirmations we're going to wait for on the blockchain. So once this is sent off, it will automatically start asking the blockchain, has this transaction been received yet? And then once the transaction has been received, it will wait for a number of blocks to be confirmed before it triggers on transaction confirmed. And the number of blocks is configurable here, so I'm going to say 3. Time between checks is the amount of time between it's asking the blockchain how has it been confirmed yet. I'm going to leave that at 5 seconds. So now, once the transaction has been confirmed, we're going to go to a print string, and we're going to get the let's get the transaction hash. So now press compile and save, and then press play. And something to remember actually is make sure that on your phone, if you're using MetaMask for example, you'll need to go to the top and select the same test network or whichever network you're using. Whichever network your smart contract is on, you'll need to set that in the header. So once you've logged in, press K and you'll get a confirmation sent to your wallet. So on your wallet, you'll need to press confirm. And you should see transaction submitted. And then if you go to your output log, at the bottom, you'll see these get transaction statuses. Now, initially it will say message transaction null, and that's because it hasn't been picked up by effectively being picked up by the blockchain yet. Eventually you'll see it come through like this, so the whole transaction and the amount of confirmations at the end here. So currently we're on 0 confirmations, which means 0 blocks have been mined after the block that we are trying to enter into. And then hopefully, depending on the chain, it might take longer or shorter, depending on how much mining is going on. There we go, so confirmations 1. And we're hoping to get 3 confirmations. So this might take a little bit of time. The reason why you want to wait for confirmations is just in case you end up with entering a block which the chain, the consensus of the chain doesn't agree is the correct block, which would effectively mean the transaction never happened. So now we have 2 confirmations. And now there we've got 3 confirmations. And after we get, so it's going to actually get to 4 confirmations before it actually sends the thing. So here you can see I've just output the transaction hash, and what you can do with that is if we go back to Etherscan, we can put that into the search bar and you'll get the transaction details. So you can see we've now got 5 block confirmations, and you can see like more information about it. So function increment count, the method, what the contract was, which contract it was posted to, who it was posted by, when it was, etc. So now that you've increased the count using that write function. If you press J again, you'll see the number is now 16. Previously it was 15. For you, it will start as 0, and now it'll say 1 or 2 or however many times you've called increase count. So we've just had a look at how you can read and write to contracts. You can also grab all the blueprints we've just made from the sample project. So let's look at how you can work with a existing NFT. So I'm on OpenSea, and this is an NFT I've made. It's a model of some sunglasses. And this is an ERC 1155. So what I would do is I would go to click on the contract address down here, which will take you to Etherscan or Polygon Scan. Then I go to contract, go down to contract ABI, copy the ABI to the clipboard, go back to Unreal Engine, right click on the back, Web3, contract, and we're going to call this sunglasses contract. Paste the ABI in, press find methods, and that'll find all the methods. If you wanted to work with a lot of different ERC 721s or 1155s, you might just want to get the generic ABI, like the shared ABI between them, and that will allow you to effectively treat them all as the same contract. Obviously, that would mean if there are specific methods on each contract, you wouldn't be able to access those for each one, but it would mean that you could call them all generically. Like, for example, every ERC 1155 is going to have a balance of if it's implementing the spec correctly, and the majority of them are going to have URIs if they're implementing the OpenSea metadata spec correctly as well for 1155s. In fact, other than this particular method here, this might as well just be a generic ABI for an ERC 1155, because this particular one doesn't do anything special, shall we say. So after I've done that, I'm also going to need to make a deployed contract of the same thing. So sunglasses deployed contract, and I'm going to select the blockchain, which is Polygon, and I'm going to select the contract, which is sunglasses contract, and I'm going to go back up to the top, copy the address, paste it into address, press save, and we now have those 2 contracts set up. So now once we've done that, we're going to go back to our example we just made, and I'm just going to update the example for the read method first. So let's say we want to get the data about the sunglasses. We'd go sunglasses deployed contract. In the method name, we'd go down to URI, and URI does take a content here. It is the ID. So for this one, it's just 0, And the way you can find this on an ERC 1155 is you'll see token ID here, and it's actually 1. So it's a good job I checked it. And this is on the OpenSea page. So just down here, token ID 1. So what I'm going to do is put 1, and then the response from a URI method, it returns 1 URI. So the URI is effectively, usually it points to either a web address or an IPFS address which contains metadata about this token. So what I'm going to do is I'm going to drag off of here and do get data from URL, which is in Emergence helpers. Then I'm going to plug the output of this into URL, and once that's completed, we're just going to print the thing as a string. So now, and the good thing here to note is, now that we don't need to get the player's wallet address, we can actually call this without even logging into Emergence with the overlay. So watch this. If I press J, you'll see it comes up there. So I'm just going to go to the output log, and you'll see first things first, it does the read method. It gets the response, which is a URL, and then it sends a GET request to that URL, and that responds with the contents of the data that lives there. So we get the description, which is the same one as you'll see on OpenSea. You'll see the name, which again is the same one as you can see on OpenSea. You'll get the animation URL, which is how I'm able to show a model on OpenSea, which is a GLB. And of course, if you have like GLTF runtime, which is a plugin for Unreal, you could actually load this into your game. And there's also the image, which you could display in the game if you wished. The same, again, is true for writing to it. You could do some mint. If you go to your Sunglasses Deploy contract, if we had a mint method, it would show up here. Let me just pick a different one. So let's say you were able to mint still on Bored Apes. I'm going to select the Bored Ape Yacht Club contract, and you can see this is where you would have called mint ape if it was still possible to mint new apes. Have fun making stuff with Emergence. Thank you for watching.